Hey class, welcome back to our graphing of logarithmic functions. We've graphed exponential functions and we've learned that there's a relationship between them, and you know what, there's a relationship between their graphs as well. So hey, let's get in there and take a look. So as we're working with logarithms, we did learn as we were introducing them that they can have different bases, and we had properties with log base b, etc., and that base can be any number. Well, there are two bases that we're going to work with and on a very big regular basis. And the first one is the common logarithm, and that one has a base of 10. So let's just take a look at that. So when we think when we have a log base 10 of x, because it's so common, we just don't write the 10 anymore. We just write log x. So when you see the log button on your calculator, that is log base 10. So if I had something that was like log of 1,000, you're going to think of log base 10 of 1,000. And of course, 10 or 1,000 can be written as 10 to the third. So we could simplify that as 3. Now our properties, when we write this, we're not going to write the logs or the bases. So log 1 is still equal to 0. Log 10 is equal to 1, right? Because it's log base 10 of 10. Log 10 raised to the x power will be x, and 10 raised to the log of x is equal to x. Likewise, we're going to have the base e. Remember, that was that really fun number. This is on the calculator as well. But now, log base e of x, we call it the natural log, and it's abbreviated ln. So ln x, a lot of times when I'm handwriting it, I'm going to do it in cursive so that you don't think that's a 1n. So ln x. So if we have ln e to the 7th, you're going to think that, think log base e of e raised to the 7. So that would simplify to 7. Here's our properties. ln, natural log of 0, I'm sorry, I did that wrong. Natural log of 1 is 0. The natural log of e is 1. The natural log of e raised to the x is x. And e to the natural log of x is x. So we're going to use those same properties even though we're not, just want to get used to using those with the same bases. So now we're going to do some graphing, and I want to show you how it's related to an exponential function. So we have the exponential function f of x is equal to 3 to the x, and we've done this one before. When x is -2, y is 1/9. -1, y is 1/3. 0, 1, 1, 3, 2, 9. And forgive my drawing of this, but I'm going to attempt to do this well, but I think I went over a little bit too far to the right, but you get the idea. Now, when we are going to do a logarithm, if this base is the base down here, and the exponent is here, that's our exponent, this is going to be an inverse function. That means the x and y are going to trade places. And I'm going to just get rid of these. I should have taken them off of my thing. So I'm going to have -2 over here and 1/9. -1 here and 1/3. 0, 1, oops. And I'm doing this wrong. -2, well, -1, 0, yeah, okay. And then that's going to be 1 and 9. Oops, 9 here, 2 here. And you're going to see that it's going to reflect over the line y equals x. So, going to come through. Oops, that's too far up. Looks something like that. If you do it on your calculator, you'll see it a lot better than I just did. So if graphing a translation, graphing a logarithm is the inverse, we just take x and y of an exponential. What do we do when we have a translation, such as this one? We've got log base 4 of x minus 5. So we're going to find the inverse function first. Find that inverse function. So we'll take this, we'll make it y. Y equals log base 4 of x minus 5. Remember, when we're finding inverse functions, we change the x and y positions in the equation. Log base 4 of y minus 5. And let's write this as an exponential equation so that we'd have 4 raised to the x is equal to y minus 5. So that gives us y equals 4 raised to the x plus 5. So that's our function. We could say f of x, right? The inverse is 4x plus 5. So if I have that original function as f of x is equal to log base 4 of x minus 5, and I found that inverse right here, I'm going to start giving myself some xy points there. So negative 2, I plug that in. 4 to the negative 2 is 1 over 16 plus 5, so it's going to be 5 and 1 16th. Negative 1 will give me 5 and a 4th. 0 gives me 6. 1 is 9. And 2 is 21. Well, that's that inverse. We know this is going to be the inverse, so I am going to reverse the x and y, and I'll have 5 1/16th, negative 2, 5 and a 4th, negative 1, 0, 6, 1, 9. I didn't trade those places. Try that again. 6, 0, 9, 1, and 21, 2. So I'm going to have these points, 5, negative 2, down here. I'm going to come through at 6, 0, and it's going to come like that.